When we write code, whether it's Python or in any other language, HTML, JavaScript, CSS, Java, C++, C Sharp, or anything, we're simply writing text files. And we use tools like PyCharm to edit the text files. Now, PyCharm is an IDE, so it does all kinds of other stuff. But the reality is we can write code simply by using Notepad or TextEdit with a text file, saving it to disk, and then using a command line program to compile or run our code. That would be okay, and that's what we've been doing so far. But to be honest, that's not how most coders code. They do one extra step. They do use text editors, how do we say, but they don't simply store their text files on disk. They use another kind of software to manage their text files, to manage their source code. And this other kind of system is called a source code control system, or sometimes a version control system. So you'll see the acronyms SCCS or VCS as generic terms to talk about software to help us manage our source code. Well, what's so important about source code that needs to be managed? Why can't we just store our files on disk, just like we store our Word documents and anything else? And the answer is that the reality is we don't simply store our Word documents on disk. We back them up. We use Dropbox, which if you pay your extra $4 a month will provide version control. Or we use Google Docs to support collaboration, where it lets us continuously track all of our changes and see how things have changed. And with programming, source code is no different. We need backup, we need version control, and we need collaboration. And it turns out that the specific ways that we code and the way that we tend to collaborate, our needs are just a little bit different. And so rather than using other solutions, programmers use special systems for managing source code control that provide these three core functions: backup, version control, and collaboration. And it turns out that these three things are really, really important. Even if you're not collaborating, even if you're doing all of your work by yourself on a single computer, surely backup is important. We know that for obvious reasons. But version control is important too. It's important because it's so easy to write some code, go down a path, and realize that it was just a bad idea, that you messed things up, you broke your code, you picked a bad data structure, and you just want to back up to where you were, say, 2 or 3 hours ago. But if you haven't been continuously saving your code as you go along and maintained every version, how are you going to go back to just the right place 2 hours ago? Right? Unless you were just really careful and happened to save a particular version at that point, you won't have it. And it turns out version control is important not only for mistakes, but it enables creativity. It enables you to say, hey, I want to try something out. I don't have to worry about messing it up because it's so easy for me to go back. If you use a good source code control system, not only will you avoid losing your work, but it'll actually enable you to be more creative by letting you easily explore new directions without risk of messing things up. And then eventually you do get to the point where you want to collaborate with other people. And then you have a real challenge. How are you going to say, well, I was working on this file and you work on this one. And now it turns out, what happens if you go ahead and modify one line in the file that your friend was working on? Well, now you're really in trouble, because how are you going to combine the fact that you've got both been modifying, some of the same files? You might have been modifying different parts of the file, so the modifications didn't really conflict with each other. At least conceptually they didn't. But yeah, you go ahead and look at your code and try and figure out who changed what, and it's a real mess. Source code control systems are great for supporting that kind of collaboration. In fact, it even works if you collaborate with yourself. That is, suppose you're at home and you're working on your desktop computer maybe, and you check in your code and you go to school and you didn't bring your desktop computer because you weren't planning on programming, and you have a couple free hours and you realize that you've got some time to work on your code. Wouldn't it be nice if you could check out the code onto whatever computer you're in front of, make your changes, check it back in, and then when you get back home, you can check out the changes you made at school? So Even if you're not collaborating, the collaborative support turns out to be really useful because it enables you to work on your code across multiple computers in a completely safe way. There are a lot of different version control systems that have grown up over the years. Traditionally, people have used CVS and SVN. Commercially, people often use Perforce. And these days, it's more common to use Mercurial or Git. Git actually has been getting a lot of visibility lately, and it's the source code control system of choice for most open source projects. And that's what we're going to use. Before we dive into how Git works, I just want to draw a little sketch for exactly what the general processes are for source code control system management and use. Let's take a quick look at how source code control systems work in general. We have a bunch of files, right? This is how we start off without a source code control system. They just sit on our disk. But the interesting thing is when we define a repository, and then what we can do is take our files and commit them to the repository. And when we do that, each file gets stored in the repository. And the reason this is interesting is that when we go and modify the files and commit those changes, right, then all of those changes are stored with every version we ever created. And so a repository can end up being a database of hundreds and hundreds of versions of every different possible version of the file. And we can go look at that history. We can compare any one version against another. And if we want to if our repository got modified by, say, another computer or another user, and we want to update our files to reflect some changes in the repository, we do that through the update process. So commit writes from our files into the repository, and update writes to our files from the repository. This is the basics, and it's as simple as that. Git goes a little bit further, and it's kind of clever, really. What it does is it stores the repository, the full database for your project, on your computer. And then in addition, it optionally has a master copy. And the master copy is what everyone collaborates around. So when you're working locally, you could even be working offline on an airplane and check stuff in, because it'll be going from your files into the repository, which is on your disk. And then when you are ready to take your changes and do a big commit, you want to push them out to the master repository, you do what Git calls a push. Now the master repository, it turns out, is just a repository. So it looks like the same kind of thing. It's a database of version files. The only difference really is that it is labeled as the master, and different people can have the repository linked to the master. So you can be working locally, and then when you're ready for to commit to the big master repository, because you're really confident that it's good, you do a push. And similarly, if you want to pull down from the master into your repository, you do that with what's called a pull operation. So in class, when you're just running locally, we won't have a master set up, and you'll just go between files and repository with commits and updates. But if you ever see me working and I'm taking my code and I'm working locally and then I want to push to the master, I'll do that so that, for example, the public files examples from our videos get stored on GitHub. And I do that with a push, so it gets stored on the GitHub master, and then you can pull them down from the GitHub master down into your repository and into your local file system.